Hello, my name is Steve Bowler, and in this video we're going to be taking a look at BGP Border Gateway Protocol. Specifically within Border Gateway Protocol, we're going to be taking a look at the outbound route filtering mechanism and capability of BGP. This is a newer capability in BGP which allows BGP speaking routers to send their prefix lists that are attached to the neighbors to each other, and basically the filtering will be done instead of on the receiving side, say on router 1 here, for instance. We'll go ahead and put in here just a couple of routers that networks that we're going to be advertising. For instance, in this case, we have router 1, which has several networks here. On router 2, say we have a prefix list inbound on router 2 that's going to just allow the 10.0.1.0/24 network. What would happen in this case if we just had an inbound prefix list tied to the BGP neighbor statement with router 1 is that all of these updates would be given to router 2, and router 2 would process all of these extra routes too and deny, router 2 would basically have to process all this extra information that it basically does not need. So what router can do kind of preemptively is, proactively, is tell router 1, hey, look, you're sending me all these networks, however I only want this one network. And this is called outbound route filtering. So in essence, router 2 will be sending to router 1 its prefix list. Router 1 will be receiving the prefix list from router 2 and will only send out what router 2 is allowing in its prefix list. So let's go ahead and get into the command line here, set these routers up, and configure this. It's a pretty straightforward feature here, not too much other than what I just specified here that goes on. It's a great feature and it works very efficiently. The main goal again is to alter the number of prefixes that are going to be sent from router 1 to router 2. It's going to reduce that amount, so router 2 will have to a lot less processing burden on router 2, and then it'll also work for router 1's advantage too, because it will it won't have to send as many updates out to router 2. Say one of these extra routes beforehand without outbound route filtering, say if router 2 is just allowing the the one network inbound, well, what would happen before using outbound route filtering, say the router 1 is sending the 2, the 3, and the 0 network. Well, if the 2 network goes down, well, it's going to send out the update to router 2, but in this case router 2 doesn't even care because it's filtering it inbound anyway. So as you can see, with outbound route filtering, we're going to actually, the amount of BGP updates that router 1 is going to have to process and send out to router 2 is going to drop as well. So it's a win-win situation here for both router 1 and 2, and I guess I can stop talking now and get in and start configuring these routers. And it was introduced, let's see here, I believe in 12.0, iOS 12.0. Again, I could be wrong there. You might just want to double check that. Um, what we're going to do here is we'll just set this up real fast. Both of these routers. It'll only take us a second. We have the serial 00 on both routers pointing towards each other, and the network between them is the 172.16.12 network. We'll give them a /24 subnet mask. Do a no shut here. And we'll use, router 1. We'll just make this as simple as possible. It will be AS100, and router 2 is going to be AS200. Again, we're just going to peer to the interface, basically the other side of this directly connected point-to-point interface here. So we're just going to connect from router 1. We're going to connect to 172.16.12.2 is who we're going to peer with. That's router 2, and remote AS here is going to be 200. On router 1, we also have a couple of loopback interfaces here. Okay, so let's go into router 2 here and get it configured. So what we're going to do here is we're going to go ahead and configure, the BGP connection between the two autonomous systems. We're also going to, we're going to bring that peering adjacency up, and then what we're going to do is we're going to advertise, these 10 networks into BGP in router 1, and then router 1 is going to push them to router 2. Router 2, we're going to have a prefix list that's going to be filtering all the networks except for the one network, the 10.0.1.0/24 network, that is. And then we're going to just take a look at some show commands, some debug commands. We're going to take a look at and see what's going on here between the two routers before using outbound route filtering and afterwards. So let's go to serial 00 on router 2, point it to router 1 here. So 172.16.12.2. Do a no shut. And we'll go on set up BGP, router BGP 200 is the AS, and then we'll just point the neighbor to router 1, 172.16.12.1. Oops, no need for subnet mask there. Remote autonomous system, in this case, is going to be 100, which is router 1's AS. Let's go ahead and try to ping router 1 here, 172.16.12.1, and we have connectivity. As you can see here, our BGP adjacency has come up with router 1. We can verify that just by doing a show IP BGP sum. As you can see here, we have the neighbor which is router 1. We have the version is 4, BGP version 4. AS is going to be 100. And then you can see we've been up for about 12 seconds here when we are not receiving any prefixes yet from router 1. So let's go ahead on router 1 and look at our BGP table. Just do a show IP BGP. And as you can see here, we do not see any of the loopbacks that are being added into the BGP table, and that is because these loopbacks are a class, they're all class A's. And so what we need to do is, they're class A's, but they're actually using, a /24 subnet mask. So what we're going to have to do is go under BGP and enter the network statements in here to allow them in. So what we want to do is the network 10.0.0.0. Let's just go ahead and do this and see what happens here. 0.0, 1.0, 2.0, and 3.0. Now if we do a show IP BGP, as you can see, we don't see anything here. So let's do a show IP protocols. Let's do a debug IP BGP. Let's do it clear. Okay, so let's do a show IP BGP on router 1. As you can see, we're still not seeing them. It's because we have to specify the mask on the end of these network statements. Because again, like I was just saying earlier, they're class A's with the /8. So what we need to do is, if we're going to advertise them into BGP, it has to be an exact match within the network that we're advertising and the subnet mask. So under the loopback interfaces, they're all /24s, but these network statements are just /8s. They're all 10 networks. So we're going to do a mask statement here. So we're going to specify the /24 mask for all these networks. As you can see here, now we're seeing some BGP messages here, applying map to find origin. So it's actually going to go out here and getting to basically the BGP origin code. So now on router 1, if I do a show IP BGP, you can see all the networks are in there now. So we have basically converged our our routing table with our BGP table, and those networks are being added into BGP, and so we should see them, best case scenario, we should see them now on router 2. So if I do a show IP route BGP on router 2, you can see that we're learning them via router 1. So let's go ahead and try to ping just one of them. It's 3.1, and as you can see, we are successful here. So with this implementation, it's going to work. However, it's what we're going to do here is just do a debug IP BGP updates on router 2. Then we'll go here and we'll just create a prefix list. IP prefix list is going to be, let's just call it ORF. And statement 1 is just going to be permit 10.0.3.0, and then it's going to be a /24, and then enter. And then what we want to do now is basically what we're going to do on router 2 is filter all of these routes from router 1 in the 10 range except for the 3 network. I know before I said the 1 network, but you know, times have changed. So we're going to go ahead and filter the 3 network here. I feel like picking on everybody else. So the 3 network is going to be allowed in. All the other ones, sorry, you don't got what it takes. So we'll go under router BGP 200 on router 2, and the statement we have to do here is the neighbor 172.16.12.1, and then follow it up with prefix list, and then the word here is ORF, because that's the prefix list that we just created. And then of course in or outbound. Of course this is inbound, since they're coming from router 1 to router 2, so that's in. And last but not least here, we just need to do a clear on the neighbor. So we'll do if I do a show IP BGP or show IP route BGP, you can still see all the networks, because whenever you're doing filtering, route maps, prefix list, distribute list, etc., you always want to do a clear in BGP. So we can do a soft clear on the neighbor. So clear IP BGP neighbor, or sorry, let's see here. Clear IP BGP 172.16.12.1, and we'll just do soft. And now, as you can see here, you can see here received refresh request, and basically that's router 2 is sending that request to clear, to soft clear the neighbor. So the outbound update from router 1 to router 2 is being sent now. However, as you can see, router 2 is denying the 0, the 1, and the 2 networks. So as you can see here, some unneeded workload on router 2 to deny these routes. If I do a show IP route BGP on router 2, I'm sorry, why do I keep doing that? Show IP route BGP, you can see now that we're only seeing the 1 network. Let's go ahead and ping it. You can see here where they have connectivity, but to the other networks, the 2 network, we don't. The 1 network, we don't. And the 0 network, we do not either. So what we'll do now here is we will set up we'll go ahead here now and set up our networks. Here we'll set up outbound route filtering. And what I'll show you here is just a couple commands that we have to do. You can do ORF outbound route filtering send, so you can send the capability. You can also set it to receive, and then you can set it for both. And what we're going to do here first is I'll show you on router 2. What we'll do is we will set it up to send its prefix list to router 1. We'll set up router 1 to receive router 2's prefix list, and then we'll go ahead and take a look and see what the difference is now that we did that. So we'll just do a show debug, make sure we still have BGP update. Okay, there it is. So on router 2 we'll just do we'll go into BGP configuration mode here. for AS200, and we'll do neighbor command 172.16.12.1, and then we're going to follow up with a question mark. And then what we'll see here is the capability command. So we'll go ahead and type that in, capability, and then ORF, which is outbound route filtering. So we're going to advertise this ORF capability to the peer, which is in this case router 1. So we'll do a debug IP BGP updates on router 1 and do a debug IP BGP as well. So neighbor, then the neighbor's IP, then the capability, then ORF, then prefix list, and then you can see we have 3 statements. One is to send the ORF capability to the neighbor, the other is to receive it from the neighbor, and then the third option is both. So we'll take a look at sending it from router 2 to router 1. We want to send the prefix list that we have for the neighbor to router 1. That way router 1 can proactively make the decision as you can see, it's still not being applied because we're still receiving the networks from router 1. So what we need to do here is go to router 1 and allow it to see, as you can see here too, we're seeing in the BGP debug, we're seeing prefix list ORF capability send for from our neighbor here, which is router 2. So now we're seeing some new changes within the BGP peering relationship between the 2 routers. But what we need to do here now is on router 1, set it up, go under the BGP on router 1. And what we'll do here on router 1, we'll just do a neighbor, then 172.16.12.2, which is router 2, and then capability, ORF, then prefix list, and receive. So we're going to allow router 1 to basically receive the prefix list from router 2, and then proactively it will not send. We should not see these networks being sent to it anymore. The 0, the 1, and the 2. So we'll go ahead and apply that to our neighbor relationship. As you'll see here, the relationship went down. We'll go ahead and do it. I'm just going to do a hard clear on the neighbor. So clear IP BGP from router 2. And as you can see here with our update that we received from router 1, we're only now receiving the 3 network, because router 1 now is using the ORF capability that router 2 is sending it. So router 2 is sending their capability, router 1 is receiving it, and it is in this case only sending the 3 network in its updates to router 2, because it knows now that router 2 only needs to is only allowing the 3 network to be permitted within its prefix list. So if we do a show IP BGP or show IP route BGP on router 2, you can see we only see in the 3 network. If we do a ping 10.0.3.1, we are successful. And the last thing I want to show you guys here with the ORF capability is we can verify this a different way by doing the show IP BGP neighbor and then 172.16.12.1 12.2, which is router 2, and then we can do a question mark here and we'll do received. So we're going to look, and then we'll follow it up with the prefix filter command. Then we hit enter, and as you can see here, we are receiving a prefix list from router 2 with one sequence in it, sequence 5, which is permitting the 3 network only. So it's pretty cool stuff. We can also actually, you know, that's probably good enough there for now to show you guys. What we can also do here on say we want to go to router 2 and advertise a couple loopbacks in to BGP. So we'll just loopback 0, IP address 192.168.1.0. I'm sorry, 1.1. Okay, so what I did is I just created 3 loopbacks, loopback 0, 1, 2, and 10. Let's go here, take a look. 192.168.1.0/24. Alright, so now router 2 has its own set of routes that we're going to advertise into BGP. We'll do that with the network statement here, 192.168.1.0, 2.0, 3.0, and 10.0. So if we do a show IP BGP on router 2, you can see here that we have those routes locally on the router that we're sending via BGP, as you can see here with these update messages. So router 1, if I do a show IP route BGP, you can see that I am learning these routes now from router 2. If I try to ping one of them, 192.168.10.1, as you can see here, we are successful. What I'm going to do now is apply a prefix list inbound on router 1, and I'm only going to allow the 10 network. So we'll just do IP prefix list ORF, and then we're just going to permit the 192.168.10.0 network. Go under BGP here, specify our neighbor, which is 172.16.12.2, and then capability ORF prefix list, and then actually, you know what, sorry, neighbor 172.16.12.2, and then the prefix list is going to be ORF. So actually, you know what, let's see here. Yeah, that's fine, we'll just do that. Neighbor 172.16.12.2, prefix list ORF, and then inbound. So if we do a clear IP BGP, now what we're going to be seeing here now is that we are sending, you know, these networks, the 3, the 2, the 1, and the 10, to router 1 from router 2. But as you're seeing here, router 1 is still now seeing the same problem. It's actually doing the filtering and not router 2. So if we do a show IP route BGP, we're seeing only the 10 network. So if we do a ping to the 10, we have reachability, but anything else like the 1 network or the 2 network is not successful. But as you can see here, we are not sending our prefix list to router 2, and we can verify that on router 2. If we do a show IP BGP neighbor, then 172.16.12.1, which is router 1, and do a received and then prefix list or prefix filter, we see we are not receiving anything. And that's because if we do a show run pipe to begin BGP on router 1, you have to remember within the asymmetrical relationship capability of the ORF command, neighbor router 1 is using the ORF capability of receive, so it's only receiving, the prefix list from router 2. It's not sending its own to router 2 and letting router 2 do the filtering on its side. So that's why we saw here when we got the update from router 2, we saw the 3, 2, and 1 networks from router 2 coming in to us, and we're actually having to deny them. So to fix this, if we have 2 links in which we have prefix lists on, we're doing filtering on both sides here, basically we just go under the neighbor and do neighbor 172.16.12.2, which is router 2 capability ORF, then prefix list, and then both. So we're going to be sending and receiving the ORF from to and from this neighbor. Now you're seeing we're getting an error here. Either capability prefix list send or receive is configured. Deconfigure it first. So we'll just do a no under the receive statement that we configured before, and we'll go ahead and put up here both. So we'll go to router 2, and we have to do the same thing on router 2. So we'll do router BGP 200, and on router 2 we'll do first we'll do a no under the send, so that way we can go back through here, and after we see the debug output here, we'll do a neighbor both. So we have the both configured on both router 1 and 2. So we'll go ahead and do that, and once we do this, what we should see here on both sides is we should see no denied statements. We should see the filtering being done on the neighbor router. And as you can see here, we are successful. We're not seeing any denied statements on either side, so they're not sending the whole, all their routes. So as you can see, this design that we have here now is a working configuration in which we have prefix lists on both sides, and we are filtering them proactively on the neighbor router. So router 2 only wants the 3 network from router 1. So we can see that here on router 1 because we're only let's see, I'm sorry, router 2 only wants the 3 network from router 1, so if we go to router 2 we can only see the 3 network that we're receiving from router 1. And if we do a show IP route BGP, we can see that network here. And on router 1 we only want the 10 network to be received, and that is all that we're receiving from router 1. We're not seeing any deny statements on either router now. So this is a successful configuration. Also, if we do a show IPBGP neighbors and then just look at the received prefix filter, this is how we can tell that we're ORF configuration. The prefix list that we're receiving from the neighbor here from router 2, from router 1's perspective, is the 3 network to be permitted, and that's what we're sending. And now on router 2, where before we were not seeing a prefix filter, now we can see that we are receiving a prefix filter from router 1, in which sequence 5 is only allowing the 10 network through. So that's why router 2 is only going to send the 10 network to router 1. If we do a show IP route BGP on router 1, and that's all we see. So that's it, guys. That's BGP Lab 7 outbound route filtering. So I hope you guys have enjoyed this video, and I hope well, actually, before I close, I just want to let you know, let's see here. Let's just take a look at the BGP configuration, and I'll just show you here again under BGP the command that we put here. So we had to put in the prefix list, that we're using to filter inbound, and then the ORF command here is neighbor, and then the capability ORF prefix list, and then either sending, receiving, or both. So again, I'd like to thank you for watching this video, and I hope you'll be with me and watch the next one. Thanks, guys.